This is section 6.4.1, Ratios and Proportions. We start with the definition of a ratio. A ratio compares quantities by division. Let's take a look at an example here. A group contains 60 women and 30 men. The ratio of women to men is 60 to 30. We can express this ratio as a fraction reduced to lowest terms. Here you can see that our ratio 60 over 30 reduces to 2 over 1. Therefore, we say that this ratio can be expressed as 2 to 1, or we can write it out as 2 to 1. There are three forms to express a ratio: the fraction form, the form with the colon, and writing it out 2 to 1. Next, we define proportion. A proportion is a statement that says two ratios are equal. We solve proportions with the cross product principle. If A over B equals C over D, then AD equals BC. So as you can see, we take the two ratios, A over B and C over D, set them equal to each other to form a proportion. Then we cross multiply. A times D gives us AD, and B times C gives us BC. Now, of course, in our proportion, neither B or D can be 0 because we can never divide by 0, and B and D are in the denominators. Let's look at an example here. When we take these two ratios, 2/3 and 6/9, set them equal to each other to form the proportion, and we cross multiply, we see that we get 2 times 9 and 3 times 6. Now, according to the cross product principle, these need to equal each other, and as you can see, 2 times 9 is 18, and 3 times 6 is 18. Now let's solve this proportion for x. Of course, x is the variable, it's our unknown, and we need to solve for it. From the previous slide, we know that we solve by cross multiplying. So let's cross multiply. X times 7 is 7x. And 63 times 5, well, 63 times 5, 15, carry the 1, 315. Now we have a very simple equation that we can solve for x by dividing both sides by 7. The 7's cancel out, leaving us with x. 7 goes into 31 4 times, with 3 left over. 7 goes into 35 5 times. X equals 45. Let's solve this proportion. This one's a little more complicated. Notice we have x, but it's located in two different parts of the proportion, and it's a part of an expression x minus 10 in the denominator of the ratio on the left. Now, solving is no different. We're going to cross multiply. Let's start by taking 30 times x minus 10. And that's going to equal 20 times x, which is 20x. Now we can solve for x. On the left side of this equation, we need to distribute our 30. So we end up with 30x minus 300. That's going to equal 20x. We need to combine our like terms. We have our x terms, but at this point they're on opposite sides of the equation, so we need to put them on the same side of the equation. So, since our constant is already on the left, let's move our 30x over to the right side by subtracting 30x from both sides. They cancel out on the left, so we have negative 300 equals negative 10x. Now we divide both sides by negative 10, excuse me, and we get x equals 30. We can verify that this is the correct answer by plugging it back into the original proportion. Let's do this to make sure. We started out with 20 over x minus 10. Well, since x is now 30, we have 30 minus 10. And the right side, we had 30 over x, and of course x is 30. Well, as you can see here, 30 minus 10 is going to be 20. So we're going to end up with 20 over 20 equals 30 over 30, and of course both of those equal 1. So we can substitute our answer back into the original proportion to verify that it is correct. All right, next we're going to talk about solving applied problems using proportions. Here are some steps for doing this. Step 1, read the problem. Step 2, set up a proportion by listing the given ratio on one side and the ratio with the unknown quantity on the other side. Step 3, apply the cross product principle. Step 4, solve for x and answer the question. All right, let's put those steps to practice here in this example. The tax on a house whose assessed value is $65,000 is $825. Determine the tax on a house with an assessed value of $180,000, assuming the same tax rate. All right, so we've read the problem. Hopefully you understand. Now we need to set up our proportion. We start by setting up our ratios. So one ratio will have values that describe the same house. So for example, the assessed value of this house is $65,000 and its taxes are $825. Since those numbers both apply to the same house, they're going to go in the same ratio. This will equal our other ratio that has an assessed value of $180,000. We put that on top because our top number over here was the assessed value of the house. 180,000 will go over the tax rate for that house, or excuse me, the amount of taxes in dollars, and at this point we don't know what that is. That's what we're being asked to find. So setting up this proportion, just so you understand here, we have the assessed values on top, and we have the taxes on the bottom in both ratios. Now it's time to cross multiply and solve. So when we cross multiply 65,000 times x, we get 65,000x equals 180,000 times 825. Using a calculator, we have 148,500,000. Now we're going to divide both sides of this by 65,000. On the left side, we're left with x. And on the right side, we're left with $2,284.62. Now, applying some common sense, some estimation, some logic, we can conclude that this is a good answer because it has a higher tax amount corresponding with the higher assessed value of the house. This has been section 6.4.1, Ratios and Proportions.